Hi guys, these are the notes for 4.5, dealing with triangle congruence. So this is the last part of proving congruence, right? We went over side, 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 angle, side, angle, and angle, angle, side. The last one is called HL. And what we'll start is we'll actually kind of skip this first little question, and I'm going to go right into the theorem of HL theorem, which stands for hypotenuse leg. Okay, so this brings you back to right triangle. So what I'll actually draw up here, right, is a right triangle. This is your hypotenuse. This is leg A, and this is leg B. Okay, just to reiterate those things. So it says if the hypotenuse and one leg of the right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. Okay, so right, if we look at the picture, two sides are congruent, and one of them is a hypotenuse and one's a leg, right? And they're congruent to their corresponding sides, so we can say that triangle LMN is congruent to triangle RPQ. All right, so let's look at example 1. It says, what information is needed to use for the following shortcuts? So the first one is angle, angle, side, right? We need two angles together, right? And this side is not included. So, right, we need to mark these angles right here. That does not include those pieces. So we need to say that angle C is congruent to angle G. Right, that's what we need to add to it. Look at the next one. Well, we know vertical angles are congruent, so we have two angles, right? And we need a side included, so in between. In between the two angles, well, that would be EF and SF. So EF is congruent to SF. What about side, side, side for up here, right? Three sides. They share this side, so we already know that one. So we need these two sides together, right? So we need XI congruent to KJ. And then the last one, hypotenuse leg, right? That means the hypotenuse and one of the corresponding legs are congruent, right? So we need the hypotenuse. That's what we're missing. So we're missing TU congruent to EF. Okay, so that's what we would need to prove HL. These were the other ones. Example 2, what we can do is go through a proof chart, right? So we're given a perpendicular bisector at JL and KM, right? So that means that this is also a right angle, right? And these are congruent angles as well, right? So number 1, okay, we're given that JK is congruent to LK. Right, that's what we're given. Okay, so that's a given. Number 2, right? We know that KN is congruent to KN, right? Because they share that same side. Right, so that'd be the reflexive property. Right. We can also prove that the right angles, because we know that um, given that JL and KM are, so JL is a perpendicular bisector with KM, right? That's a given, right? And because of that, it gives us two right angles, J and K, and angle L and K are right angles. Ooh, that says triangle. Right, and that's by the definition of perpendicular bisector. Next one, we can also say that now the triangles there, right, J and K, is congruent to the triangle L and K, right, and that's by the hypotenuse leg theorem. Right, we're given their hypotenuse and the legs and Kn, right? So we can prove that those are congruent triangles because of the HL theorem. All right, and then also we know this big piece, right? Km is congruent. Oh, Km is congruent to itself, right? By the reflexive property. And then that also tells us JKN, right, is congruent to LKN, right? We know that by so JKN, angle JKN is congruent to angle LKN, right? And we know that by the corresponding parts, right, of the triangle. And then the last piece is to prove that triangle JKM is congruent to triangle LKM, right? And how do we know that? Because we have a side, we have an angle here, and then we have another side. So that's kind of just showing you what a proof would do. Most of the time, we're probably not going to do a proof, but this just kind of show you the chart proof. All right, so now what we're going to look at is our right triangles, and we want to prove the HL theorem, but we need to find out what we need to add, what information needs to be added to this to tell that they are congruent triangles by the HL theorem. So we know they're right. We are given the hypotenuse are right congruent. So we need to prove the legs. Well, we're given 1 is 12, but we're not given this one, and we're given 28. We're not given this one. So we either need to say that AC is equal to 28. Sorry, not 28, 12, right? Or DE is equal to 28. Right, so either one would prove, right, if any of the sets of legs are congruent, right, and the hypotenuse, then the triangles are congruent. Right. Then the next one, we are given their right triangles. We know this leg right here, this PR for both of these triangles are congruent. So we need, right, PQ and PS to be congruent. So we need PS equal to 15. Right? And that would prove that we have a hypotenuse and a leg that are congruent of a right triangle. So the triangles are congruent. Okay, the last thing is using um, that these triangles are congruent by the HL theorem, right? We know that our hypotenuses are going to be congruent and the legs are going to be congruent, right? So to solve for A and B, right, we need to start setting things equal to each other. So I'm going to set 15 equal to 2A plus 7 and solve for A. So I'm going to minus 7 over 8 equals 2A, so A equals 4, right? And then we look at B, right? So we know 3A plus B is equal to 4A minus 3, but we know what A is, right? We're using the fact that A is 4 and substituting it in here. So 3 times 4 plus B is equal to 4 times 4 minus 3. So we get 12 plus B equals 16 minus 3. I'm going to minus the 12 over, right? So minus 3 is 13 minus 12 is 1. So B is equal to 1. All right. And then the next one, same thing. Hypotenuse, set them equal to each other. 2A plus 3B is equal to 5B plus A minus 1. And then the legs. So we're going to have to solve for A first using the legs being equal to each other. Right, so I'm going to minus 2A over and add 2 to both sides. So we get 3 equals A. Right, and then I need to substitute in right this 3 for A and for here and here. So 2 times 3 plus 3B equals 5B plus 3 minus 1. So I get 6 plus 3B equals 5B plus 2. Right, and then I'm going to subtract 3B over minus 2 over, right? So we get 4 equals 2B. Therefore, divide by 2, B is equal to 2. And that's it. All right, that's it for the HL theorem.